Hi Jade, this is Mrs. Ballard, and I'm going to go through the homework questions that you wanted me to go through real quick, okay? So this first one says, let f be continuous, let f be continuous such that it goes from 6 to 2 is f of x dx equals 9, and from 6 to 9 if f of x dx equals 6. First of all, this is a problem right here because you always want the smaller number first. So you have to reverse that. And to reverse that, you go 2 to 6 and you put a negative out in front. That's one of the properties that we have for integrals. Then you'll notice that they want us to to figure out what's going on from 9 to 2. So I'm going to break this up actually into two integrals. So I have the integral from 2 to 9 of f of x dx, and again I can apply this property, plus the integral from 2 to 9 of 4 dx. Well, I know this piece of it here, I know I can add up from 2 to 6 and then from 6 to 9, and that would give me that piece there. So that's going to be from 2 to 6 of f of x dx plus from 6 to 9 of f of x dx plus, and then we've got this part back here. When I integrate that, I get 4x from 2 to 9. The only other little catch that I kind of missed here is that we know that this is equal to 9, so I got to take that negative and put it to the other side. So that means from 2 to 6 of f of x dx is equal to negative 9. All right, so I'm ready to start plugging things in. So this is going to go in for this first thing, so negative 9. And then for this part here, I've got this 6, so plus 6, plus for this back part here, I'm going to plug in 4 times 9 minus 4 times 2. All right, so we're just going to do the arithmetic. So negative 9 plus 6 is negative 3. 4 times 9 is 36 minus 8. And let's see, 36 minus 8 would be 28. And then plus negative 3 would be 25. All right, the next one you said you had trouble on was this one. It says that f is shown below is comprised of a semicircle and a piecewise linear segments. They want us to figure out the area there from negative 7, and I'm sorry, my pictures are super small. Oh, there, it's better. From negative 7 to 6, which is only to here. So what that means is we need to find the area of this triangle here, find the area of that little triangle there. I've got, oops, sorry. It is not liking me right now. Apparently I erased it. We've got the area of that rectangle right there. I lost my triangle, the little triangle there. And then we've got the area of this circle above here. Okay, so we need to find those areas and add them up. And it's signed area, so that means that down below here, that this area is negative because it's underneath the x-axis. So I'm just going to start doing that. So my green one here, it looks like it's got a base of 2. So triangle area is 1/2 the base times the height, which it looks like the height is 4. And it's the whole thing's going to turn out to be negative. And then the little blue one. So the blue one right there looks like I've got a base. It's what triangle again, so plus 1/2. The base looks like it's 1, and the height looks like it's 2. And then we have this rectangle right here, and the rectangle looks like it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So plus 10 times a height of 2. And then we've got this circle, which it looks like we got to know where the radius is at. So the radius is right there. So the circle is pi times the radius, which it looks like the length of the radius is 5 squared, but we're only doing a semicircle, so we need to cut it in half. All right, let's go ahead and do those calculations. So it looks like 2, ooh, it disappeared on me. It's not what I wanted. Oh, how did I hit eraser? Sorry, I'm learning this new one. Okay. All right, so it was a 1/2, and we're gonna grab that. Okay, so 2's cancel, so it looks like I'm left with -4. Those 2's cancel, so I'm just left with +1. That gives me 20. And then it looks like plus 25 halves pi. So up here I could put this, it was 21 minus 4, which is 17 plus 25 halves pi. And then I don't know if you need to put it in a calculator or not for that one. So you can put it in a calculator if you need to get it simpler than that. All right, this next one says that we have to let f be the function defined by this. Not right now, Andy. If 4 subintervals of equal length are used from the left Riemann sum, and I have to go from 1 to 2 on that left Riemann sum, we're supposed to round to the nearest thousandth. Okay, so the easiest thing to do is to set up a table. So this is going to be my x, and this is going to be my f of x. I know I have to start at 1 and I have to end at 2. All right, and I need 4 subintervals, so I have to go 1, 2, 3, 4. So, like that, like that. Okay, so I need numbers in between there. I know exactly halfway in between is 0.5. I know in between those would be 0.25, and I know in between here would be 0.75. I'm going to put these numbers into x to the 4th. So when I put that into x to the 4th, I get 1. If you bear with me, I got to do my calculations on my calculator here. 0.25 to the 4th. Not sure that's right. Yeah, that's right. 0.25 to the 4th power. I'm getting 0.0039. And then 0.5 to the 4th. 0.0625. 0.75 to the 4th power. I've got 0.1364. And then 2 to the 4th power is 16. I have to do a left Riemann sum, so I'm coming at it from the left. I know I only need 4 subintervals, so I'm going to make places for 4. My distance in between this first one is 0.25, and then the height is 1. My distance in between the next one is 0.25, and then the height, I did not leave myself enough space for this. And then the height is 0.0039. My distance in between again is 0.25, and then my height is the 0.0625. And then my distance in between, I messed up somewhere. Distance in between there is 0.25, and then the height I'm going to use is this 0.1364. And then all you got to do there is just add those up, and you should get the answer. All right, this last one, we're going to calculate the integral expression. We have to use U substitution. Let me see if I can get orange. There we go. Okay, so we would always use orange for our U, so I'm going to do that too. So my U is equal to 8 minus 3x squared. So that means that du is equal to -6x dx. I see the x. So let me go with my blue. I see the x. I see the dx, but I'm missing the -6. So I'm going to have to fix this up a little bit. So I'm going to multiply top and bottom by this -6. So -6 times -6. And we're going to do some fancy algebra moves here. I'm going to take this 8 and move it out, and the 3 and move it out. And then I'm going to take this -6 and move it inside. So bringing the 8 out and bringing the 3 out. I still have a -6 in the denominator there. I'm moving the -6 in. And then I've got an x inside still, and an 8 minus 3x squared to the 1/3 inside. All right, so I'm going to match things up. Here is my u. Okay. And then this part here, this -6x dx, that's my du. So now I'm going to substitute in. So here I could simplify a little bit. I know that 2 goes into both of those. So 2 goes into 8 4 times and into 6 3 times. So I've got -4/9 out front from the negative right there. And then my u is the 8x to the -3/2, and that's to the 1/3 power. Actually, to the squared, not 3/2, and that's the 1/3 power. And then for the du part, I'm substituting du for -6x dx. All right, and now we're just going to go ahead and integrate what we've got. So we've got -4/9. And then remember, we add 1 to our exponent. So you get u to the 4/3 power. Sorry, that did not come out very well. And then we divide by the new exponent, or we multiply by its reciprocal, which would be 3/4 plus c. Normally I would have put that in the front. So if I did put that in the front, it would look like -4/9 times 3/4 u to the 4/3 plus c. And you'll notice that we can cancel those 4s. 3 goes into 9 3 times, so it looks like I'm left with -1/3. I need to replace my u with the u that I had before, which was this right here. So that needs to get substituted in. So 8 minus x to the second, minus 3x to the second, sorry. All right, and then that should be your answer.